So in this video, we are going to learn a little bit about the messaging queues. Okay. So let's take an example. Okay. You are in a restaurant or you are running a restaurant. Okay. And this is the customer you have, and this is you. You are the cook. Okay. So he goes to you and place an order. Okay. Let's say he says that make me chicken biryani. Okay. You take the order, go for cooking. Okay. Make chicken biryani. Okay. And after preparation, you go to the customer and say that the chicken biryani is ready and you can have it. Okay. This happens at time T1. Okay. And you deliver the chicken biryani at, let's say, time T3. Okay. At time T2, which is between time T1 and T3, what happens? There is another customer. Okay. He doesn't find you. He can't find you. So he thinks that your restaurant is closed and he moves away. Okay. So this is a loss for your restaurant. Correct? So what can we do in this condition? So this is what you can do. You can keep a person, okay, who will take the order and tell you that, hey, we all this uh, orders have been made. You prepare and give it to me, and then I will serve. So what happens at time T1? Okay, this customer goes to this guy. Okay, he tells that, hey, make me chicken biryani. Okay, chicken biryani. Okay, anywhere, anything. Okay, so he goes to you, okay, and in a, let's say, poster he says that you need to prepare a chicken biryani. Okay, chicken biryani. Okay, and then he says that order is received, and he order is received. In this process, okay, the another customer can also come. He can also say that, hey, I need a paneer biryani. Okay, paneer biryani. Okay, he just puts this inside this poster. Okay, not poster, actually you can say it is inside a queue. Okay, and he says that your order is taken, acknowledged. Okay, now as a cook, what you do, you see this queue. Okay, you first see there is a chicken biryani order. You prepare the chicken biryani. Okay, you prepare the chicken biryani and tell him that, hey, chicken biryani is made. He goes and serves to the customer C1. Okay, then you see that, okay, now there is paneer biryani. So you take paneer biryani, make it, then you send this guy. Okay, and he serves the paneer biryani to this customer. Okay, now let's say that the number of customers are increasing in your in your restaurant. Okay, so what happens in this case? So you hired a second cook. Okay, so you hired a second cook. So now what happens? So there are like three customers. Okay, he goes, he says that I need chicken biryani. Okay, chicken biryani. This guy puts the chicken biryani inside the queue and says order received, order received. Now this guy goes and say I need paneer biryani. Okay, he puts this paneer biryani inside this queue and he says order received. Okay, order received. Then this guy goes and say that I need a pizza. Okay, I need a pizza. He puts that inside the queue. Okay, he puts this inside the queue and says the pizza, your order is received. Order is received. Okay. Now let's say this is cook number one. This is cook number two. Okay. So CK1, CK2. Okay. So he goes to the queue. He picks up the order number one. Okay. Now he prepares chicken biryani. Okay. Once it's now he's preparing the chicken biryani, and let's say he need 1 hour to prepare chicken biryani. Okay, at the same time this guy goes to the queue to the queue. He takes the second order. He started preparing paneer biryani. Okay, paneer biryani. Okay, he, and let's say this needs like, let's say, 30 minutes. Okay, after 30 minutes, when he says this guy that can you go and serve paneer biryani to this person, he serves this person paneer biryani, and then again he takes the third order from the queue, which is pizza. He cooks the pizza. Okay, and says this person that can you go and please serve the pizza, and then he serves the pizza. So what we have seen, that client actually doesn't have to wait until the cook has finished its like preparations, like finished the dish, right? So there is a person in between who is putting everything in queue, and whoever is free, let's say this cook is free, so he took the pizza order, right? So they can like take any order. So this is how the asynchronous thing happened. Okay, and there was a queue in between, which is taking all the orders, which is listing all the orders. Anyone who is free is taking up the order and uh, processing it. Okay, so same thing happens in servers also, in distributed systems also. So let's say you are in a distributed system where there are three masters. Okay, master one, master two, and master three. Okay, and there are all the worker nodes, and let's say this is the coordinator node. Okay, so the client goes to the coordinator node, says I want to do process P1. He says I want to do process P2. He says I want to do process P3. All those things, coordinator node, what it does, that it puts inside this queue. Okay, now anyone who is free, let's say M1 is free, M1 will go to this queue, start processing P1. Okay, M2 is free, he will start processing P2. Okay, and M3 is free, now he will start processing P3. Now someone came and gave an process of P4 also. Okay, the coordinator node will put this P4. Okay, now whoever finishes its job, it will pick up P4 from the queue. Okay, so these guys don't have to wait for like masters to complete the work. So what are the pros and cons of this whole process? So the pros and cons were, so this is client one, this is client two. Okay, so client one gave some work. Okay, and now this this server basically takes like 1 hour to complete the work. Okay, so this guy have to wait for 1 hour until the process is done. He cannot accept any other work until this process is done because the thread is stuck waiting for this process to finish. And if in between some other process also come, then he have to wait, let's say, for 1 hour for completion of this, and then 1 hour for processing his request. Okay, so for his request will also, let's say, take 1 hour. So you have to wait for previous 1 hour, which is consumed by C1, and another 1 hour, which will be for his own process. Okay, and he cannot take any other jobs. Okay, so what we are doing by putting Q in between, we are decoupling. Okay, so in this case, what we are doing, so this is C1 and C2. Okay, now what he will do, he will just put the work inside this queue, and he will get the acknowledgement, and he can take some other task to do. Okay, he can do anything, any other thing. Okay, similarly, he will put his task over here, and he can do some other things. Okay, whenever the server is free, he will just pick up from the queue, complete it, and send it to the client. Okay, or maybe there can be a coordinator node in between. He will send it to the coordinator node, and coordinator node can send it to the client. Again, when it is completed, he can again take it from the queue. Okay, and complete it. And if there are like multiple, it's even better. Like whoever is free takes the work and does the thing. Okay, so this is the basic reason why we use a messaging queue. Okay, so now let us understand what are all the times when a messaging queue is being used. So messaging queue is all, we can also call this as like a streaming process. Sorry, not a streaming process. Yeah, yeah, we can also call it as like a stream process. Okay, so now let's see what are the applications of a stream process. Okay, so the applications can be matrix slash log events, change data capture, or event sourcing. So the example which I just explained right now was one of the example of event sourcing. Okay, we will understand it little bit even more. Okay, but let me go through one, like each of the use cases. Okay, so let's see first log events. Okay, so in a typical distributed system, what happens that you are, obviously if you are doing anything, you have to, like, you are making logs. Why do you need logs? For debugging in future, or like for debugging in future. Okay, let's say now the logs are stored in a let's say .txt file. Okay, now when you write in a .txt file, obviously you have to write, you are writing it on a disk, correct? And writing it on disk is like a slow process, we know that. Okay, so what actually happens in most of the distributed system, that let's say a log is being generated. This is the timeline. Okay. So what happens? Let's say in RAM, what we do, we store this much amount of log, let's say this much amount of log, and then we flush it directly to the uh, like to the disk. Okay, to the disk. Okay. So there are like three concepts which we have to understand. Then I can like make you understand it even better. So basically what I wanted to say is like we store one, let's say 1 KB of logs inside the RAM, and then we push that event, like some other thread can come and take the log from that 1 KB of log from the RAM and then like commit it inside the disk. Okay. Now how are the logs being, so let's say this is the producer who is creating the logs. Okay. This is the broker where like I said, like 1 KB of data is being stored in RAM. Okay. Once the 1 KB is there, then it sends it to the broker. Okay. And this is the consumer. So there are three kind of time windows which we can use. Okay. One is like tumbling window. So what is tumbling window? So let okay. So basically each of the windows are like processed by the consumer. Processor producer have the, so like it can be sensor or logs, whatever. Okay. So that what basically tumbling window means is that it's non-overlapping window with fixed interval and fixed time size. Okay. So you can see over here that the windows are not overlapping with each other, and they are of 1 minute uh, interval. Correct. And the second one is hopping window. In hopping window, basically the buckets can overlap. Okay, so let's say we are having a overlap of like hopping window of 3 minutes. Okay, so in this 3 minute we have this three buckets. In the next hopping window we will have next three buckets. In the next hopping window we will have next three buckets. Okay, so this is hopping window, and last but not least, we have sliding windows. So sliding window, we can implement something like in-memory queue or in-memory linked list. Okay, and the application is like you want to see all the events which happened in last 5 minutes. So what happened? You told that I want to see all the events which happened in last 5 minutes, and each minute's logs or events are stored in each of the linked list. Okay, so what it will do, like it will go behind the linked list and show all the events which happened. Okay. So in which kind of scenario can this be used? So let's say you are a monitoring platform. Okay. And monitoring every live action is like too much heavy workload on your server. So what you do that every 1 hour you get the batch of events and then process them. Okay. So basically you want to see, for example, uh, let's say you are Google, okay, and you want to see like what is the most frequently searched word, let's say most frequently searched word. Okay, so what you do, like if you keep on processing this every request, then you are screwed. Correct. So what you do that you put an event kind of thing. Okay, and every 1 hour you get all the like searches and then process them, and then you see that uh, okay, Nasdaq, let's say Nasdaq is the most searched word. Okay, and second is AI, third is something else and something else. Okay, so in this kind of scenarios you can use this metric slash log kind of use case. Second is change data capture. So change data capture comes in a scenario. So let's say you are the client. Okay. Uh, let's take the example of the Instagram video which I have created some months ago. Okay. So there was a table. There were two tables. One is a person is following, like let's say this is a person A and he is following, let's say B, C, and D. Okay. And also there is a table where I want to see like who are all the person who is following A. Okay, who are all the person who is following A? So let's say B is following, and let's say Q is following, and D is following. Okay, but if we want to update both of of this DB at a time, we need to use two-phase commit or things like that. And we all know that two-phase commit is like extremely slow. So what we did over there, we only put this changes inside a database. As soon as these changes are made in this database, the changed data is propagated to a Kafka queue. Okay. And as per that data, we filled another database which was making this. Okay. So both database have the data and there is no screw ups between the data, and there is no risk like if one database get updated and another doesn't get updated. Those kind of problems are also fixed, and we are not even using two-phase commit. Okay, so this change data capture is like very important. Or you can, yeah, this is the best example which I can come up with. And third application was event sourcing. Okay, so I gave you one example of event sourcing, but let me like tell you another example. Okay, so let's say you are Amazon and you are doing a sale. Okay, so as soon as you are doing a sale, you want every people to know about the sale. Or let's say you are Amazon and someone made a order. Okay, and you want to like tell that person that you have made the order via mail, WhatsApp. Let's say you are sending a message to Instagram message also, and you are sending a message in Facebook Messenger also. Okay, so what you do, that you put it inside a queue. Okay, now there will be a service for sending a mail, there will be a service for sending WhatsApp messages, there will be a service for sending Instagram messages, and there will be a service for sending Facebook. What they will do, they will take the message from the queue. Okay, they will take the message from the queue and send it like however they want to send. Okay, so this is also one of the example of event sourcing. Okay, cool. So in the streaming process, few of the principles which we have to like take care is that every message should be processed at least one times, and no message should be processed more than one time. Okay. So what I want to say, let's say this is P1 and he put him, so this is like client one and he puts a process P1. Okay. This is client two and he puts a process P2. Okay. So let's say like the consumer one, consumer two, consumer three, all of them are free. So what happened? Consumer one took P1. Okay, so he took P1. Consumer took 2 took P2. Okay. At the same time, consumer 3 also took P2. Now what happened? That P2 got processed two times. This should not happen. Okay. So this thing we have to take care. So how can we do this? We will obviously understand about this in upcoming videos, but one way is like use two-phase commit. Okay. So there will be a coordinator node. Okay. There will be a coordinator node. So these guys won't take directly from the queue. They will contact coordinator node. So let me just make the picture actually. So what happens? Like there is process P1, there is process P2. Now if C1 is free, he will first go to coordinator node that, hey, I want to take some job. I am free. What can I do? Now coordinator node will go and see that if there is any job free or not. Okay. So he sees that, okay, P1 is there. Okay. So what he does, he marks P1. Let's say he marks P1 like processing or something, processing. Okay. And then he says the broker, okay, now you can send P1 to to C to consumer one. Okay. So now process one is sent to consumer one. After that, C2 wants to take some job. He will go to coordinator node that, hey, I want to take some job. Okay. So he coordinator node will mark P2 also, okay, in the processing list. Okay, and send broker that, hey, send P2 to consumer 2. Okay, so he sends it to consumer 2. Now when C3 goes to coordinator node, he sees that is there any process which is not marked as processing. He sees that there is nothing, so he says C2 C3 that, hey, there is no job for you, come back later. Okay, but obviously, when we have this whole process of coordinator, node, and all this thing, we are using two-phase commit, and which is extremely slow. Okay, so what we can do, we can make each of these processes idempotent. Okay, so one way how we can make it idempotent is like each processes or like each events basically should be having a like key value pair kind of thing. Okay, so let's say broker sends consumer a event which is having key, let's say 50. Okay, he processes it. Now again the consumer asks for a message. Okay, something happened. Okay, and the broker again sent the same event uh, whose key was 50. So consumer says that, hey, I have already processed 50 number key, so please don't send it to me again, send me another job. If there is any another job, then it will the broker will send to consumer. If there is no another job, then okay, there is nothing to do. Okay, now the things which have we have to take care inside this broker is basically it should be fault tolerant. Okay, so first the events should be stored inside a persistent disk kind of like area, persistent in a persistent layer. Okay, second, it should be replicated. It shouldn't happen that the broker someone came and like some disaster happened and the broker went down and now all the events are lost. Okay, so it shouldn't happen. So the broker should like save the events inside disk. It should be replicated properly. Okay, and the third thing is broker should actually manage the acknowledgement which is coming from the consumer. It shouldn't happen that like consumer took up event and then consumer went down. Okay, now that event is the broker is thinking that event is done, but actually the consumer never came up and the event is actually lost. So broker should wait for the consumer for some amount of time. If the consumer is not replying, then what it should do that it should again put that event inside the queue. Okay, so that next if there is any next consumer, he can come and take that event and finish the process. Okay, so this is all about the streaming process and asynchronous like messaging queue and everything. Okay, we will go even more deep inside this topic in upcoming videos. Thank you.